So 11th question is a beautiful question. If wind speed is V and it's a windmill that is generating electrical power, then if the wind speed is V, the power output is proportional to what power of V? It's a question. And let's try to write what is happening here. In the problem, it is given that a fraction of wind energy is converted into electrical energy. Then the fraction is equal to output energy, and let's call it output energy by input energy, and the energy output is equal to the fraction converted into energy input. And by time, if we put, so energy input by time is called power output equal to beta times power input. So the output power is electrical power. So the electrical power is equal to the fraction of energy that is converted into the input power. Input power is actually the power is due to the wind energy. So the input power is the wind energy per unit time. So then beta times the wind energy is the kinetic energy of the wind half into mass of the wind into velocity square by time taken. But this is usually not a very common way of expressing that, because how do we calculate the mass of the wind? But the point is, you know the density of air. So let us try to write that in terms of that. So the electrical power output is the fraction that is converted into electrical energy into half into m into v square, where v is the mass of the air per unit time. Instead here write like half into mass of the air per unit time, mass of the air blowing through the windmill. Suppose this is the windmill and this is rotating. So within this area, how much mass of the air that is passing through per unit time into v square. We know that density equal to mass by volume. Then mass is equal to density into volume. So density is more appropriate because we can easily calculate the density of air. So replacing that up here, you know that the electrical power output is beta, the fraction converted into 2 into mass by time, can be written as density into volume by time into v square. Then density is a constant. Now we can take it out. Beta rho by 2 into volume of the wind blowing, per unit time into v square. Suppose when the wind blows in t seconds, the length of the air column that is passing through this windmill, let us say, is L. So then the area of cross section through which the area of the effective area of the windmill that is converting the wind energy into electrical energy is the area of the fan. Suppose through this area A, if L is the length of the air column that is passing through the windmill that is generating the electricity, we know that in time t seconds. So in t seconds, the volume of the air column passing through the windmill is area into L. Then in 1 second, so the volume of the air column passing through the windmill is A times L. So which can now be written as beta into rho by 2 into this volume of the air column passing through the windmill is area of cross section of the rotating fan into length by time into v square. So half into beta into rho. So length by time, length of the air column by time is velocity of the air column. So area of cross section into velocity square. So the electrical power output is equal to half into beta into rho into A into V cube. Beta is the fraction converted, rho is the density of the air column, A is the area of cross section of the windmill, the effective area of cross section that is converting the energy. So all are constants. Hence the electrical power output equal to some constant into V cube. Hence the electrical power output is proportional to V cube, which is our option C.